All right, for today's deep dive, we're getting hyper-specific. We're looking at a core problem for video system integrators.
A really fundamental one.
Yeah. How do you take a perfect, clean 1080p live feed, say, from a camera or a Blu-ray player, and get it to work with both old-school TV antennas and modern internet streaming?
And the piece of hardware that tries to solve that exact puzzle is the Thor Broadcast H-1HDMI-ATSC-IPLL.
That's a mouthful.
It is, but it does a lot. It basically takes that HDMI signal and outputs it into two completely separate worlds.
Yeah.
RF for coax cables and IP for networks.
So let's unpack the first part of that, the legacy side, ATSC.
Right, the Advanced Television Systems Committee. It's the standard for over-the-air broadcasting here in North America.
And this box specifically uses something called 8VSB modulation.
Yeah, 8-level vestigial sideband. And what's really interesting here is that, well, that choice is a deliberate trade-off. It's what defines our broadcast environment.
Trade-off. How so?
Well, other standards, like QAM or DVB-T you see in Europe, can actually pack more data into the signal. They have a higher theoretical bandwidth.
Okay, so we're giving up some bandwidth. We top out at what, around 19 megabits per second? What do we get in return?
You get reach and reliability. The 8VSB modulation is just incredibly robust over very long runs of coaxial cable.
Ah, so for someone designing a system for a huge stadium or a university campus.
Exactly. For that system architect, knowing the signal will be perfect at the other end of a long cable is way more important than squeezing in a few extra megabits of data. Signal integrity is king.
And I imagine if you're injecting a new channel, you need more than just a strong signal. The TV needs to know what it's looking at.
Oh, absolutely. You need that seamless integration. And that's all handled through a web interface on the device.
So you can control everything from your computer?
Everything. You can edit the PSIP tables, which is the program and system information, basically the channel guide data. You can set the audio codec to Dolby AC3 to make sure it works with older TVs. Full control.
Okay, so that covers compatibility. But what about speed? The name has LL in it, which I'm guessing means low latency.
It does. And for live events, it's everything. It's the difference between the system being usable or completely useless.
Really? How bad is the normal delay?
A standard encoder can have a delay of 700 to 1200 milliseconds.
Wait, that's up to a full second of lag.
A full second. Now, if you're watching a pre-recorded show, you'd never notice. But for live news or a football game, it's a deal breaker.
So this LL feature, how much does it cut that down by?
It crushes it. It brings that delay down to between 70 and 120 milliseconds.
Wow.
Yeah. It's about a 10-fold improvement.
Yeah.
And that's what makes professional distribution of a truly live event actually viable. It keeps everything in sync.
That is a huge capability. And this one unit is doing more than just the RF side, right? It's kind of a hub.
It really is. You have the ATSC RF output we've been talking about, but you also get a DVB ASI output, which is sort of the professional standard for connecting broadcast gear together.
And the modern side of things.
And the modern side, it has a dedicated IPTV streaming output. It supports unicast, multicast, all the network protocols you need to send that stream reliably across a huge corporate network or campus.
So to sort of bring this all together for you, the listener, what we have here is a single box that's managing massive engineering trade-offs on the fly.
It's choosing cable reliability over raw bandwidth on one hand, and then choosing millisecond speed over a full second of delay on the other.
All to bridge these two completely different worlds, the old terrestrial broadcast RF and the new internet streaming.
And if we pull back to the big picture, it really highlights something fundamental. This hardware exists to connect two separate technologies. It's a bridge. So the real question to think about is, what happens when that bridge isn't needed anymore?
When those two distribution methods finally merge into one single platform.
Exactly. What does that world look like? That's something for you to explore.
A perfect thought to end on. We hope this gives you a better sense of the complex engineering that keeps our video world running.